Now suppose if I ask you, I have a ester. Now this ester, if I add Gilman's reagent where I have alkyl group attached with copper plus 2 ion, will there be any reaction? Now the basis, the parameter, the standard compound that we consider for reactivity difference between those kind of alkyl compounds where you have negative charge on alkyl group and you have a metal ion bonded with alkyl group, in that case what happens is the reactivity decreases, reactivity decreases drastically because the negative charge is tightly held with the metal ion because of poor shielding of the nucleus from the outermost electron. So this R minus is very strongly bonded with a metal ion, whether you have cadmium or you have copper. So in that case the reactivity decreases. When this reactivity decreases, it is not able to react with the compounds having reactivity equal or less than carbonyl compounds. Now ester is much less reactive than carbonyl compound because in carbonyl compound you have a ketone. You have this R group is giving electron to this electron deficient carbon through plus I effect, through inductive effect. Here this oxygen will be giving electron to this electron deficient carbon through plus M effect. Now plus M effect is much stronger than plus I effect. This we have seen in great length before already. So this ester is very less reactive. There will be no reaction in this case. If we add R minus with attached to copper plus 2 ion, or for that matter if I add dialkyl cadmium, R is attached with cadmium, there will be no reaction. Now suppose if I add Grignard reagent, RMgX, then definitely there's going to be some reaction because this is how, I mean you haven't done experiment and you have seen yourself with which reagent substrates react and with reagent it does not. But the whole beauty is, without doing laboratory experiment, still you are able to solve problems with conviction. Still you have faith in what is written in the book and what your teacher is saying, and still you believe in that, and you can work out problems and you can fetch good marks. That is ultimately important. Now I'm giving you a very strong information, and this you have to bear in your mind, that the reactivity difference is such that if you have a D block metal ion, either you have copper plus 2 or if you have cadmium plus 2, then their reactivity is such that they don't react with compounds equally or less reactive than carbonyl compounds. That means if you have any electron giving atom attached to carbon, then that will decrease the reactivity of this carbon because of electron donating nature, and that will decrease the reactivity of whole of the compound, and this dialkyl cadmium or Gilman's reagent will not react with this ester. But if we add R minus attached with an element of a metal of S block like magnesium, then this is not going to have a strong hold on R minus. That metal ion is not going to have a strong hold on R minus. So R minus is not very binded with the metal ion. It is free enough to put its electron into the empty orbital of carbon or any other electron deficient atom and show reaction. So definitely in case of Grignard reagent you are going to have the reaction, and in great length we have already seen how the reaction of Grignard reagent is with the ester. But I would like to add here, if we have RLi, RLi means lithium. Of course we know lithium will have a plus charge. If lithium has a plus charge, R will have a minus charge. So basically you have a R minus and Li plus. So in this case again we can see that lithium belongs to S block. In S block you have a strong shielding of nucleus with the outermost electron. So in this case the attraction of the nucleus with the outermost electron or the electron outside the shell will be stronger. So this R minus will not be stronger because the shielding is stronger, will be poor, will be weak. So this R minus is not greatly attached with this Li plus. So this R minus is free enough to put its electron into the outermost, into the empty orbital of some other atom. So this R minus again will be much more reactive. So this R minus in fact is more reactive than Grignard reagent, because in Grignard reagent you have magnesium plus 2 ion. That plus 2 ion offers greater attraction to this R minus. On lithium you have only plus charge, and that plus charge offers less attraction to R minus. Plus 1 charge offers less attraction to R minus. So this R minus in lithium alkyl compound will be more reactive. So this is what you have to bear in mind, that if you have metal ion of D block, less reactive, metal ion of S block, more reactive, divalent, less reactive because of greater attraction, monovalent metal ion, more reactive because of less attraction. Now let's solve a conversion problem. Now here it is, a very small conversion, easy, simple, and I have made this conversion much more simpler by giving you very easily this phenol. Now the conversion is and these alphabets are by no way symbols of any elements. Like this F is not fluorine, this F is some compound, organic compound that you have to identify based upon some of the given information. Now look at this, the information that is given here, very strong, and the key to solve this conversion is this phenol. I have given you that if you react B with oxygen, subsequently adding H plus, you get a phenol. Now you have to go back into your memory and scan all the reactions that you have studied in organic chemistry that results in formation of phenol, and that will not be many of them. In that reactions, among those reactions, then you have to zero down to the particular reaction in which you add oxygen to something followed by hydrolysis. This H plus will be doing nothing but hydrolysis, and that results in formation of phenol. And because as such the syllabus we haven't covered much, so you don't have to give much pressure into your mind to remember such reactions. This reaction we have done just in the previous section. We produced phenol by reaction of Grignard reagent with oxygen, forming a peroxy linkage. When we add H plus H2 into it, that peroxy linkage hydrolyzes, giving you a alcohol. So you know how to add OH group through Grignard reagent, and by seeing this step from A to B, you are adding magnesium and ether. I am getting some kind of sense that you are producing Grignard reagent, because Grignard reagent is produced like that. When you add magnesium and ether to alkyl halide, you get Grignard reagent. So by looking the step from A to B, I have some sense that Grignard reagent is being produced, and when you add this reagent to Grignard reagent, then OH group is added instead of Cl. Instead of the R minus get attached to OH. So that results in formation of alcohol. Now the structure of phenol is this. Now in B you are not having this OH. This OH is added due to this reaction, this reagent that you are adding. So in B you'll have the rest of the part except OH. So this rest of the part will serve the purpose of R minus in the Grignard reagent. So the Grignard reagent of B must be pH minus Mgx. I'm not showing charge on magnesium and X because they are stable. So this negative charge has to be at this end where OH group is added, because that is the end where the reaction occurs, and that will be called as pH minus, that will be a phenyl group. So I have written B as pH minus Mgx because looking at the structure of phenol, I'm getting this idea that if I use pH minus, if I use this negative charge here, then oxygen will get added at this point, forming peroxy linkage, and on subsequent hydrolysis that water group will be removed off. The detailed mechanism we have seen in the previous section, I hope you remember this, and that will result in formation of phenol. So this conversion is a very tiny conversion. As the syllabus proceeds ahead, we'll do a conversion from A to Z. So this is just a warm-up, and in these kind of conversion, one step may not be sufficient or may not be clear enough to decide upon the product or decide upon the reagent. You have to look around, a step before, a step ahead, two step before, two step ahead, to give you the idea of what that substrate should be. So from this step A to B, I got the idea it must be Grignard reagent, and then I zeroed down to B. Now B must be pH minus Mgx. Once we have identified B, that will be very easy for us to identify A, because that A must be Rx, that will result in R Mgx. So this Mg must not be there, and this R and X must be somehow bonded in A before this R Mgx was formed. So what A must be? A must be pHx. This X could be chlorine, could be iodine, could be bromine. We'll not take fluorine because with fluorine the Grignard reagent preparation like this is not possible, because the bond with fluorine is stronger with of carbon. So magnesium do not get inserted so easily, and compounded with the fact that F minus is not a good leaving group, as you have Cl minus, Br minus, or I minus. So if you have fluorine here, Grignard reagent will not be prepared. So this X must be chlorine, bromine, or iodine.